Welcome everybody. Today we're going to do a quick demo of the GitLab Openshift operator. This is the beta MVP, so understand that any hiccups or bumps you may see here is going to be resolved in the coming months, some of them very quickly in the next couple of days or weeks. Our intent is to be able to install the operator into an Openshift cluster. We're targeting 4.7, by the way. 4.6 is what our functional CIs are running against. We want to be able to deploy, configure, reconfigure, as well as make sure that all of the components work. I will call out, as documented, that we do currently have it defaultively deploying with a self-signed certificate. We're working through a couple of issues with Cert Manager inside of Openshift. That's not directly under our control, so bear with us in that regard. I will say we have, though, proven out that you can indeed deploy with your own certs and everything will work perfectly fine with a publicly trusted certificate. So without further ado, I will hand it over to Mitch.
Hello everyone. So we'll be running through a demo of the GitLab operator today. We're excited to show you what the process looks like at the moment as we're targeting MVP for this month's release. And so what I'm going to do is walk through our own documentation for how to deploy the operator, and we'll test it out and show a running instance of GitLab, and then we'll also show the process of changing the configuration in GitLab that we want to deploy and confirm that the necessary objects are updated as we want. And so our homepage here is on the screen now. This is our GitLab operator project. And so what I'm going to do is open up the doc folder here in a new tab. This is our documentation. If you want to look at this after the demo, everything from standing up an Openshift cluster to deploying the GitLab operator will be here. A quick note, right now a lot of our project code and documentation references Openshift, but the ultimate goal is to be able to support deploying this GitLab operator on Openshift as well as just raw Kubernetes as well. And so we'll be working towards that as time goes on. So where I'm going to start is installation. The first process technically is to do the Openshift cluster setup, which is documented here. Effectively, this uses some Openshift tooling and some shell scripting to create a project in GCP that will stand up some instances to act as a Kubernetes cluster and install Openshift on top of it. That will give you a running cluster as well as a domain name that you can use for accessing your services. So we'll skip right to installation as I've already done the cluster setup since it takes about 45 minutes or so. So we'll see the next portion of the requirements here is to clone our repository. And a quick note, this process is kind of just for our MVP early days installation of the operator. Eventually our target is to have this actually hosted in Openshift Operator Hub so that you can do a one-click install from a UI without having to clone our project and run our local make targets. So I already have the project cloned over here, so what we'll do is switch over to that. Here I have the project cloned. We're on the master branch, and here is the Openshift cluster that I've created with the startup script. So the next step here is to run make install required operators. This confirms that Nginx ingress operator and cert manager are installed. Now right now Nginx ingress operator is not leveraged in Openshift. Openshift defaults to HA proxy and automatically converts any ingresses we create to routes. And so those routes will talk directly to the services, bypassing Nginx entirely. So this will be required in a non-Openshift environment, which is why we have it here. And Cert Manager at the moment is used for creating the certificate for the operator's webhook to watch for resources. We're working towards support to confirm that Cert Manager can be used in Openshift for creating certificates for TLS on the GitLab, MinIO, and registry ingress endpoints as well. So I'll run that command to install the required operators. It applies some manifests from our repository. Next up is to deploy the CRDs. At the moment we just have the one, a custom resource definition of a GitLab. Just like we have built-in definitions of objects like deployments and stateful sets and services, Uh, in the case of an operator, we have to define what a GitLab is, and so that's what we will be applying here and telling the cluster how to work with that. Next up, we will deploy the operator. This creates a deployment in the cluster along with some service accounts that give it permission to control the resources related to GitLab. And so I will deploy that now. This will create a new namespace called GitLab System. So you'll see here that's our newest namespace in the cluster. I'm going to press enter on that, and it will list out the pods in that namespace. So we'll see here as that container starts to run, we'll check the logs. What it'll do is start up and elect itself a leader, so it can be the one to manage the resources in this namespace. And it'll just start up and wait for us to send it a resource like a GitLab. And so right now it's just sitting and waiting. The last step here is that we'll actually go ahead and deploy an instance of GitLab. So we have a custom resource definition of what a GitLab is. Now we'll hand it a custom resource of that kind, GitLab. So before I do that, I want to show you what that file actually looks like. So if you're familiar with working with deployments and services, this manifest will look very similar. You can see the kind is GitLab, and then under the spec here, we've got our own specifications for what defines a GitLab and how to work with it in our operator. So the top level key here is chart. Our GitLab Helm chart kind of serves as the heart for the operator. We run a template of the Helm chart within our operator and then can deploy and upgrade and change certain resources based on logic that we can program into the operator itself. So this chart version will determine what version of the chart to use in the template. By default, we ship the last 3 minor patch versions of the GitLab Helm chart. Right now, the latest version in there is 4.10.3 will be the default. An important one is global host domain. This is also important when deploying the raw Helm chart. This tells the ingress resources which hosts to specify for accessing those services. And then here's some others that we use in CI but are also common uses in case you want to use a custom TLS certificate. That's available as well. And this is at the bottom is just a temporary fix that we're making in the upstream Helm chart. So what I'm going to do is I'm going to specify my domain. This is the domain that comes with the startup script will be created for you in GCP. And so it will inject that into that CR that we just looked at and apply it to the cluster. So now in the logs, you'll see that the operator has noticed that we have deployed that new GitLab resource. So it says that it's reconciling GitLab, rendering a new template based on the values we just passed it. You can see here it takes a hash. This is based on the version of the Helm chart and the values that we passed to it so that we can cache it. Templating the Helm chart takes a little bit of time, so if the values and the version haven't changed, we just keep a cache of that template. If any of that changes, the hash changes, in which case we'll generate a new version of the template, which we'll see in a moment. Now you can see the operator is starting to create some objects in the namespace. So far it's created a config map and a job. So if I back out of the logs here from the controller, we'll see that it's starting to create the shared secrets job. The process from here will look a lot like the Helm charts once you've run Helm install. And so we'll just give a moment for all the resources to get started here. Alrighty, now we can see that all the services are in a running state. What I'll do next is come over and list the ingresses that were created from the operator. Since we've got min.io, registry, and web service. To go to the web app, we're going to copy this URL, go to the browser, open it up. Now we'll get this error because for now it's using self-signed certificates generated by our Helm chart. As I said, we're working on support for using Cert Manager to create authentic Let's Encrypt certificates for these endpoints. Just working through some gotchas in Openshift specifically with the Cert Manager operator. So what I'll do is just tell the browser that this is okay for now. Proceed to the home screen. We'll log in as root just as we do with the Helm charts. I'll grab the login password. And we're in. So we can see that we have the default monitoring project. What I'm going to do as a quick test is just create a new project and demo pushing some code to confirm that all the services are talking to each other correctly. So I'll call this demo, give it a README, and create. Next up, I'll open the README and push some changes using the web editor. And it looks good. The next test is I want to confirm that object storage is working appropriately. So for that, I'm going to open up an issue and try to attach a screenshot. So we'll take a screenshot of the logo here, copy it to my clipboard, and paste it into the issue. Looks like it's working. We'll submit the issue. And it looks good. So the next step that I want to demo is that the operator can support changes to the resources. So what I'm going to do is come back to the example of the GitLab resources that we were looking at. And as you can see, we have the option here to pass in host suffix, just like the Helm charts. So I'm going to do that. The host suffix is a good demo here because it touches a lot of resources related to the GitLab release. There's, of course, the ingress endpoints need to change. There's lots of services and config maps that need to update because they include URLs to other services. And so what we'll do is reapply that GitLab resource while specifying that host suffix. In this case, we'll make it demo. We'll jump into the logs here. We'll notice that it's reconciling GitLab. We can see that the template signature has changed, evicting it now. So you'll see we'll have a new hash now because we've changed the values provided to the template. So it'll recalculate that template and reapply the resources that have any changes. So what I'll do is leave it on this screen for a little bit. We'll see that the pods will be restarted once the new content of the config maps and secrets have been created. We should see services like Task Runner, Sidekick, and Web Service especially restarting with that new configuration. Once it's all done, we'll check in again and test it out. Alrighty, so all of the pods have been replaced with new configuration. What we'll do is go back to the ingresses screen and see that our URL has changed with our host suffix, which is great. So we'll copy that and open that in a browser. Same certificate error, so we'll go ahead and tell the browser is okay for now. Log in again. And we're back in. So we can see that everything has updated as expected as we changed the host suffix. And this will go for any changes that you make to the custom resource. Any of those values that are configurable in the Helm chart will be supported in that GitLab CR. And that will be how you manage the GitLab instance. So as a quick recap, what we've done here as part of the operator project is create a Golang code base that will be able to watch for custom resources and use the configuration defined in those resources to ensure a certain state. What's great about the operator specifically compared to the Helm chart is that we can go beyond because we're using a full-fledged programming language such as Golang in this case. So we'll be able to handle more of the life cycle of a running GitLab instance. So in the future, we'll be able to handle upgrades and backups, etc., and really take a lot of those admin tasks and bake them into the logic of the operator to help make running GitLab a more seamless and dependable process. So we're really excited to be working on this and sharing this with the world. And so if you get your hands on it and get a chance to test it, we're always welcoming feedback. Please open an issue here on our project and we'll be happy to look at it with you. And we're excited to unveil some new features as time goes on. So thank you for your time and appreciate your interest in the operator and have a great day.